Yeah, Assalamualaikum warahmatullahi wabarakatuh. So in this video, I'm going to show you how we can plot a graph, torque versus speed. Okay, for the torque speed characteristic. Okay, so from our last previous video, I have shown you how to develop the no load test. Okay, so this is the test. Okay. Now I'm going to show you what we can do, additional thing that we can add here. Okay, so let's see. Okay, we need to see again our model. Okay, 400. Okay, so since 400, so we need to make sure that here the line voltage. So in order to get the line voltage, so we must show here face to face. Okay, face to face. So then this one become V line. Okay, line voltage. Okay, so I put it as a V line. Okay, V line. Okay, this one doesn't matter because this one I and line is equal. Okay, so face to face is equal to V line. And over here, we must make sure that the output is 400. Okay, so in order to get a 400 in the output, okay, so for the input source, we must do like this, 400 times the square root 2, because here, in here, they will divide again with the divide with square root 2. Okay, and then over here, we must divide with square root 3. Okay, you can it's like a face to, it's a conversion between face to line or line to face. Okay, and then then we try. Okay, this is the degree. Degree, thing like that one. I will update the name. Okay, now we'll try first. Okay, so we need to see here, is it 400 or not? Okay, so we run it for 10 seconds. Okay, so we get it almost 400. 400 over here. Okay, so then what we want to show here is the what we need is the speed and also the torque. Okay, so in order to get the torque and speed, we can directly display to the graph. Okay, just double click here and directly write XY graph. Okay, and make sure that at the first one, the first input is the speed. Okay, speed in radian. Okay, so this is speed to radian. Okay, this is a conversion. Speed radian to RPM. Okay, this is a conversion. So this is the output is in RPM, and this is, you can directly connect. Okay, just directly connect here. Okay, so then we need the speed. Okay, so we need to increase the speed linearly. So in order to increase the speed linear, so we need to use the ramp. Okay, we use ramp, and then the slope, for faster result, we can use a higher slope. Okay, if you want to get a very precise, you can use very low. Okay, for example 0.1, but you need to run it for longer time. Okay, so to make it short, I just use 10. Okay, yeah, even though you use 10 or 0.01, a small one, you will get the same graph. Okay, because the same value, but the interval between the point to point is much more larger if you use a higher number of slope. Okay, from now I think we can run. Okay, let's run for 10 seconds. Okay, I think we need 20 seconds. Okay, I don't think it's enough. Okay, okay, you can see here, the speed is not up to the NSYNC. Okay, the NSYNC. Okay, the NSYNC. Okay, how to write here? Okay, wait. I try to open the this one. Okay, the NSYNC. Okay, the NSYNC is equal to 120 times with FE divided by number of pole. Okay, remember. So from here we can get 120 FE is 50. Okay, we use 50, and the number of pole, how to get? Okay, to get the number of pole, you need to see here. Go to here and then go to the parameter, and then we can see here pole pairs. Okay, pole pairs. So it means they have two pairs. So 2 pairs mean we have 4 poles. Okay, 4 poles. Okay, so yeah, and then divide by 4, and we will get 1500 RPM. Okay, so this is the NSYNC. Okay, so here we get 900, not enough, so we need to run it for a longer time, so we take 20. Okay, you can see here, if more than 500 we can stop. 1500 we can stop already. Okay, so 500, 700, 900. Okay, we can stop. Okay, so then we can, when we double click here. Okay, so we wait for a second to open the graph. So the graph will plot automatic. Okay. Okay, so yeah, we get the result. Okay, so firstly we can do is we focus on whatever we need. So maximum is 1500, the NSYNC. So take here until 0. Okay, from 0, and then the Y1. Okay, take here. Okay, you can take this one until 0. Focus until 0. Okay, so this is the graph. Okay, so just ignore this point. Okay, we just ignore this point at first. Okay, if you want to exclude this one, we can do several things. Okay, we can do like this. Okay, I will show you how to make it more nicer. So for example, we take here. Okay, we take for example here we can get I think 99. Okay, 69.98. Okay, so we can use sample and hold. Okay, which means that we start the block. We take the input after, for example, maybe after 1 second. Okay, so here, so step is 1 second, and then the final value just take, for example, 69.98. Okay, for example, okay, and just click here. In this equation also the same, 69. Okay, and then this one we remove. Okay, we connect it here, and this one we connect it here. Okay, then we run again. Okay, so it shows that before 1 second the value is 69.8. Okay, so after that they will follow the current graph. Okay, so let's see. Okay, we just ignore the beginning things. Okay. Okay, let's see how's the graph. Okay, lah. Okay, I can say it's okay lah right now. So yeah, for easy way we just ignore the things. Okay. Okay, and then what we need to do, actually we need to find the maximum pull out torque. Okay, how to find it? So to find the maximum pull out torque, it at the maximum point here. We need to find where is the maximum. So 9885, 993. Okay, 993, 994, 995, 996, 7, okay, 1000 something. Okay, 10, 12, 15, 16, 17, 18, 19, 20. Oh, wait, silap. Okay, we need to read this point, this point. Sorry, my mistake. Okay. So 91.69. This is the maximum. So this is the pull out torque. Okay, and the slip, okay, from here is how to get the slip. So how to get the slip, the calculation will be like this. Okay, so this is the maximum, the NSYNC. So we know that the graph, how many? 9.933. Again, 959.33 divided by RPM. So this is the slip. Okay, the S. Okay, this is slip max. Okay, this is the slip max. Okay, you can calculate it. Okay, so what is the value? Okay, it's equal to 0.6396. Okay, so this is the value, and the torque max is equal to 91.69. Okay, 91.69 Newton meter. Okay, so yeah, I think so. Then this is the ramp for the speed. Okay, because we vary the speed through we use the slope. Okay, and this is we can write either P short circuit ataupun or the P in. This is also the input because this is before the enter the motor. Okay, and yeah, then we can do a few things after this. We can also do the calculate the P converted. Okay, we also can calculate the P converted. Okay, so this is the where the P converted is equal to torque induced. Okay, so this is the induced torque. Okay, induced torque times with RPM times with the speed. Okay, then you can get the P converted. Okay, so to get the P in, so P in is already we can get here. Okay, and yeah, the P out. Okay, the P out, how you can get the P out? By times the output speed. The motor speed. Okay, the motor speed, I think will be the same like here. Okay, the motor speed time with the torque, or this one, that one we need to change. This one we need to change the speed to the torque. Okay, change torque, and then we increase it slowly, then we can get the P out. Okay, okay, or the P out. Okay, to get it to more easy, you can get it from here. So 5.4 horsepower we times with 746. Okay, then we can get the P out. Okay, so I think I will explain I think other maybe in the class or in the next video. Okay, I think that's all for this. Thank you.